My topic that I'm going to be discussing is designer babies. A designer baby is an embryo that has been genetically modified or gene edited for the sake of producing a child with specific traits. In some cases, unfavorable characteristics or bad traits, like genetic disease, may be removed, or favorable traits, like enhanced intelligence or strength, might be added. Humans and animals are the organisms used. My type of biotechnology is germline engineering. In germline engineering, there are changes to the gene in eggs, sperm, or early embryos, also referred to as inheritable genetic modification or gene editing for reproduction. These alterations would appear in every cell of the person who developed from that gamete or embryo, and also in all subsequent generations. For safety, ethical, and social reasons, there is a broad agreement among many scientists, ethicists, policymakers, and the public that germline editing is a red line that should not be crossed. Using germline editing for reproduction is prohibited by law in more than 40 countries and by a binding international treaty of the Council of Europe. However, in November 2018, a scientist from China announced that he had edited the genes of twin baby girls who had been subsequently been brought to term. His reckless experiment has been nearly universally condemned. This development has sparked new debate around human germline modification, particularly between the parties who desire to push the technology forward and those who fear it could open a new door to new market-based form of eugenics. This works through a big process that begins with embryo screening. Embryo screening involves a process called pre-implantation genetic diagnosis. Embryos are created by in vitro fertilization and grown to the 8-cell stage, at which point 1 or 2 cells are removed. This picture represents the process of pre-implantation genetic diagnosis, which again is the first part to how designer babies work. What this does is that scientists can then examine the DNA of these cells for defects, and only normal embryos are replaced in the womb. Designer babies would be very beneficial and could solve many problems. Designer babies would first reduce the risk of genetic diseases, reduce risks of inherited medical conditions, eliminate forms of pain and anxiety. It gives a child a better chance of succeeding in life. It could give us a better understanding of genetics. There could be an increased lifespan. It can give a child genes that the parents do not carry. And lastly, it could prevent next generation of family from getting certain characteristics or diseases. In addition, the people who would use designer babies are first the scientists who would modify the embryo, and then, since designer babies would be really expensive, probably only the wealthy people would be interested. Also, parents could be interested in having a designer baby if they carry a deadly and/or dangerous disease. The first time in vitro fertilization was used was on July 25, 1978. The story behind this was that a woman had black fallopian tubes. Because of this, in vitro fertilization was used. The father's sperm was first mixed with the mother's egg in a petri dish, and the resulting embryo was then implanted in the womb for normal development. However, the first designer baby was born in the year 2000 in the United States. This baby was created in order to save the older sister's life. Doctors used screening techniques to test the embryos of parents Lisa and Jack Nash. They chose the embryos that would be an exact cell match to their daughter, who was named Molly. The embryo selected did not carry her disease, and it was a perfect tissue match. As a result, Adam Nash was born in August after Mrs. Nash underwent 4 IVF cycles. Stem cells were collected from his umbilical cord to be donated and used to replace Molly's bone marrow. There are many benefits of the creation of designer babies, but there are plenty of drawbacks. Some drawbacks include termination of embryos. It could create a gap in society as well. This means that designer babies would most likely be better looking or smarter than most. This could create a quote-unquote class between designer babies and non-designer babies. Also, there is a possibility of damage to the gene pool, and the baby has no choice in the matter. Genes often have more than one use, and geneticists are not perfect and could make mistakes. In addition to this, there could be a loss of individuality. Other children in the family could be affected by the parents' decision, and only the rich can afford this. As for the future for designer babies, someday this might become a big option and possibility for people. We shouldn't expect designer babies anytime soon, though, but what's called genome editing is already transforming biological research. It's being used to develop treatments for patients struggling with a range of diseases. But if scientists learn how to safely pass alterations of the genetic code for future generations, the panel said germline editing could be attempted under strict criteria, including that it targets a serious disease with no reasonable alternative and is conducted under rigorous oversight. Thank you for listening, and I hope you became more informed about designer babies and the biotechnology behind it.